Given f of x equals the integral from 0 to x of the quotient of t squared minus 9 and 1 plus cosine squared t dt, at what value of x does the local max of f of x occur? Recall local max and mins occur where the first derivative is equal to 0 or undefined. In this case, f of x is expressed as a definite integral, and therefore we can determine f prime of x by using the second part of the Fundamental Theorem of Calculus. F prime of x equals the derivative with respect to x of f of x, and f of x is the integral from 0 to x of the quotient of t squared minus 9 and 1 plus cosine squared t dt. And again, using the second part of the Fundamental Theorem of Calculus, which shows us that differentiation undoes integration, f prime of x equals the integrand function, but now expressed as a function of x, which indicates f prime of x equals the quotient of x squared minus 9 and 1 plus cosine squared x. And now we need to determine where the derivative is equal to 0 or undefined. The function is never undefined because the denominator is never equal to 0 because we have 1 plus cosine squared x in the denominator. And therefore we can determine where the first derivative is equal to 0 by setting the numerator equal to 0 and solving for x. We can solve by factoring. We have a difference of squares. The factors of x squared minus 9 are x plus 3 and x minus 3. This indicates the first derivative is equal to 0 when x equals negative 3 or when x equals positive 3. To determine whether we have a local max or local min at these x values, we will now use the first derivative test. To do this, we'll determine where the given function is increasing or decreasing, and then from knowing that information, we can determine whether we have a local max or a local min at these two critical numbers. Because the domain of the given function is all real numbers, we break the real number line into three subintervals using the critical numbers, which indicates the interval on the left is from negative infinity to negative 3, the open interval from negative infinity to negative 3, the interval in the middle is the open interval from negative 3 to 3, the interval on the right is the open interval from 3 to infinity. And now we select test values in each of these subintervals. Let's use x equals negative 4, x equals 0, and x equals positive 4. And now we're going to sub these x values into the first derivative to determine whether the first derivative is positive or negative. And again, because the denominator is always positive, we only have to focus on the numerator. Notice when x is negative 4, the numerator is the square of negative 4, which is 16, minus 9, which is positive. When x is 0, the numerator is negative 9, which is negative. And when x is positive 4, the first derivative is positive. So now we know over the open interval from negative infinity to negative 3, because the first derivative is positive, the function is increasing over this interval, or going uphill from left to right. Over the open interval from negative 3 to 3, the first derivative is negative, which indicates the function is decreasing over this interval, or going downhill from left to right. And finally, on the right, the first derivative is positive, which indicates the function is increasing over this interval. And now analyzing our conclusions, notice at x equals negative 3, the function changes from increasing to decreasing, which means at x equals negative 3, we have a high point, or a local or relative maximum. At x equals positive 3, the function changes from decreasing to increasing, and therefore the function has a low point, and there is a local or relative minimum at x equals positive 3. So going back to our question, at what value of x does the local max of f of x occur? We now know f of x has a local max at x equals negative 3. I hope you found this helpful.